Okay, today we're going to look at some problems from section 3.3, completing the square. And we're going to solve some of these equations using completing the square. Now, it's not always the most efficient method, and there's some questions in the homework where you get to choose. And so some areas where I'll walk through where we wouldn't necessarily use that. So here's one of them, because this one actually factors, and the way you know it factors, part of it is you can tell by looking at it, you can come up with the factors, or when you see your solutions, if they're rational numbers, then you know that you could have factored the original equation. So to complete the square, for me, I like to isolate the constant term. Then we're going to take half of that coefficient of x, sometimes referred to as half the b value, which is 2. We square that as 4, so that's the process to find the number to complete the square. And now what we have created is that perfect square trinomial. And remember, a perfect square trinomial is one in which the two factors are identical. So now this factors to x plus 2 squared, and we get 9. And now we'll use square roots. And we get 3, and remember it's the absolute value of x plus 2. And then we have two equations, x plus 2 equals 3, x plus 2 equals negative 3, and we get 1 or negative 5. There's our two answers. And the original equation would have factored to x plus 5 and x minus 1, which was how we would have gotten the 1 and the negative 5. Okay, looking at number 2, again, we're going to isolate the constant term. And remember, the leading coefficient has to be positive 1. So I'm going to factor out a 2 at the same time. So now we take half of 10, which is 5. We'll square that and get 25. And so by adding 25 in here in my parentheses, we've created that perfect square trinomial. But what we have to add to the other side is the leading coefficient times that, because really that's what we've added on the left side is 2 times 25. So we have 2 quantity x plus 5 squared. So that's 50. So we get 97. And we're going to divide by 2. And we get x plus 5 squared equals 97 over 2. So this is one that, again, I don't know that I would have used completing the square, but part of what we're going to learn is how to deal with these types of numbers. So we get the absolute value of x plus 5, root 97 over root 2, rationalizing our denominator. Probably should have left a little bit more room there. We have the absolute value of x plus 5. 2 times 97 is the square root of 194 over 2. And then we'll subtract 5, and we get plus or minus root 197 over 2. Okay, and if you would like, you could make this negative 10 over 2. So we could write that as x equals negative 10, plus or minus the square root of 197 over 2. Just to be clear, let me put that negative, because negative 10 over 2 would be our negative 5. Okay, down here we're going to distribute. And so remember, we did say that the leading coefficient has to be positive 1. So we're going to multiply both sides of the equation by negative 1. And I'm going to put the w first, or the w squared rather. So half of negative 12 is negative 6. Negative 6 squared is 36. We'll add that to both sides. And we get w minus 6 squared. Again, there's our perfect square trinomial. And we will take the square root of both sides. We get the absolute value of w minus 6. And simplifying this, we have the square root of 16 times the square root of 2. So we get 4 root 2. And so we end up with w equals 6 plus or minus 4 root 2. So this one's actually a really good one to complete the square. This does not factor, and if you were going to use the quadratic formula, this actually simplifies your solutions a little bit quicker. Okay, so number 4 here, we're going to add 2. Now notice we end up with we have an odd number here. So when we take half of 5, we get 5 halves. We'll square that and get 25 over 4. So that's what we're going to add to both sides. On the left side, our perfect square trinomial is x plus 5 halves squared. Combining like terms, 2, right, is equal to 8 over 4. And since we have fourths here in our denominator, we'll get 33 over 4. Taking the square root of both sides, we have x plus 5 halves, absolute value. And using our rules of radicals, we'd have root 33 over root 4, which is 2. And now we'll have x equals negative 5 halves plus or minus root 33 over 2, or negative 5 plus or minus root 33, and we'll do the whole quantity over 2. Okay, so there's 4 problems. There's certainly some complications in there in terms of some radicals, some non-perfect squares. We have an odd number that we have to take half of and deal with that on both sides. So hopefully this gives you a good sense of some problems where we're solving using completing the square. Thanks very much, and we'll see you soon.